Imagine that I want to measure flow inside this pipe. So I got big pipe, flow going this way. So I can set up a pitot tube like this. Let's cut a small hole there. Like that. And then assume that I have manometer fluid on both sides of this tube. So I say the fluid is here. Now we know that fluid velocity in the middle is max. At this wall, the velocity is 0. So when the fluid goes this way, on this side of the tube, fluid enters through this hole, go this way, and pressurize this manometer fluid. On the other hand, the fluid that goes over that tube, it is still have the velocity, and then on right here, there is a also pressure here goes this way, which is basically the static pressure, because on this surface, the velocity again is 0. So on this hole, on this side, it will only read the static pressure. And on this side, I have both the dynamic pressure plus the static pressure. So the fluid will go like this. So this is the differential pressure, which is the delta P or just the dynamic pressure, PD, which we can write half times rho V square. So velocity head, rho of the fluid that is flowing. We can also measure this height and the manometer fluid density to calculate the actual pressure. So this delta P can be calculated as gamma of manometer fluid times H is equal to half times rho of the fluid that is flowing through this pipe. And then this gamma we can change by G rho, gravity constant, times the density. Height of the manometer fluid, rho of the manometer fluid. So then V is equal to square root of 2 rho of manometer fluid plus ZH divided by the rho of the fluid. Now here I have basically ignored the so we can say the gamma of the manometer fluid is much higher than the gamma of the fluid flowing this way. So if you think about air is flowing this way and I use water in the manometer, so that's gonna be a huge manometer fluid have very high gamma compared to the fluid flowing. So on this here, P called gamma H, I kind of ignore that fluid. But if you have very close, then you can't ignore it. So in this case, this equation will look like V equal to 2Z rho of manometer minus rho of the fluid times H divided by rho of the manometer, the fluid that is flowing, if we cannot ignore it. Anyway, we know the velocity, then we can measure the flow. Velocity equal to, flow is equal to Q by area times the flow. So to measure the flow rate.